Hello, you're welcome back to the machine learning discussion. Now, in this video, we will examine the classification supervised learning. All right. Now, in this video, what we'll do, we are going through 8 steps: introduction of libraries, loading in a built-in data sets, exploratory data analysis, data visualization, splitting the tests, training 3 supervised learning models, evaluating the accuracies, comparing model performance. All right. So here we go straight to the first one, which is to load the libraries. By now, you should be used to loading libraries. Then we load the inbuilt dataset. Datasets we've been using, the one we used in the previous video, and here they are datasets that came with either scikit-learn or any of those libraries. All right, so this is the breast cancer data, and after loading it, we are calling for head. That's the first 5 rows. All right, so you can see mean radius, mean texture. These are the attributes, the features of the breasts that are collected, data that are collected, mean perimeter, mean area, mean smoothness, and all of this to predict whether a person or a lady has breast cancer or not. All right, let's check the last 5 here. So there are 568 rows in total because it's the last 5 rows, right? So now, exploring data, we want to view the shape of the data, we want to check for missing values, and statistical summary. So for missing data, let's see, none of them have missing data. The shape is 569 by 31. That means there are 31 columns and 569 rows in this data set. All right, then these are the descriptives. So the counts, of course, is the same for all of them. The mean for mean radius, the average of mean texture, mean perimeter, and all of that. The 25 percentile, the minimum, the maximum, standard deviation, you have all of them there. The 50th percentile is the median value. The median value, right? Now, the class examine class distribution. This shows how many samples belong to each target class. How many samples belong to 0? How many samples belong to 1? So 1 is for those who have breast cancer. 0 is for those who don't have breast cancer. So we can visualize this by doing, you can see 1 is for breast cancer, 0 is for those without those who do not have breast cancer. You can apply the previous visualizations to this as well. You can do multiple bar charts, yeah, you can only do bar charts here, I guess. You can check for those who have breast cancer, what is their average mean breast perimeter, what is their average smoothness, and so on, like that. You can plot it beside each other. All right, so we've done that in visualization. Now, because we have numerical variables, let's check the correlation values of these variables. All right, so you can see for mean radius and mean texture 0.3, radius is highly correlated with the mean parameter. That's 0.99. In fact, perfectly correlated when abbreviated, and with also mean area as well, and so on. You can interpret them. Some of them are perfectly correlated, some are not. Then again, we split the data into the test and train splits. All right, and okay, firstly we split into dependent and independent variables. That's the targets and the features. We do that, and we say the features have 569 rows, 30 columns. Then the last column, which is the 31st column, is the target. All right. Now the next thing we do is to split into train and test groups. All right. So we do that using 80% rule. And how do I know it's 80%? This is important. We are splitting into 4 places, and then the train test splits. That's the main command for this row. We have the X and Y. So we have the X axis, X data, which is this, the Y data, which is the target. The 2 data, we are splitting them into 2. That makes 4. And we are using 0.2. Random state 42. Like I said, random state is used such that every time we run this, it will give us the same randomized response. And when you run into it, will give you the same randomized so that we won't be working on different data. The 42 can be anything, does not really matter. All right, so 0.2 here means that the test size is going to be 20% of the whole data. The test size is going to be 20% of the whole data. That means going to split X into 80%, 20%, then Y into 80%, 20% as well. So the 80% is 455, while the 20% is 114. All right. So the first model is the logistic regression, which is used for, this is the binary logistic regression because the dependent variable is 0 and 1. 0 and 1. So here, the same procedure, we assign the model carcass into an object. Then we fit that model with that object by passing the X train and the Y train. Once we fitted that, then we can make prediction. We make prediction by saying predict then the test value. The test set is what we use for the prediction. Then for the accuracy, we compare the outcome for the tests for the prediction with, we compare the Y test with the outcome of the prediction. So that gives us what the accuracy and any other like RMSC is. So the regression accuracy here is 0.95. So here it is, we have a very good accuracy, because the accuracy, like I said, the more it tends to 1, the better it is. The second decision tree, so that's for logistic regression. For decision tree, the same procedure. We assign the model carcass, like assign a formula inside an object. Then we fit it by passing the X train and Y train. Then for the predictors, we have case for forward to predict, we will pass in the X tests for the prediction. Then accuracy, again, we compare the outcome of the prediction and with the outcome, with the normal data that we know. Then we run the accuracy again. We have 0.94. Looking at what we have up here, we have 0.956. Here 0.947. So by a very small distance, logistic regression is better than decision tree for this data. All right, so let's check for random forest as well. Again, we pass in the model carcass into an object. We fit that object by having .fit, then the X train and Y train. Prediction predicts it by passing in the X tests. Then we compare the Y test that we know, that is we already have, with the predictions that we made. The output gives us the accuracy score. So this is 0.96. So random forest outperformed both decision tree and logistic regression. Now let's compare the 3 models by running this line, by creating a table and passing them in, the estimates that we have gotten. So you can see logistic regression 0.9, decision tree 0.94, and random forest 0.96, right? So again, we would like to plot it to see what we have. Yeah, the three models performed very well. They entered the 0.9 REM, but the random forest outperformed the three models. So in the next class, we'll see how we can use this in real life. You know, we can't do this and stop at, okay, we've known the better model among, if for supervised and for the classification and the regression, then how do we now make, um, how do we make predictions? So, you know, because what we've done here, we've seen that, okay, for breast cancer data, random forest model gives us a better outcome. So we would, if a woman comes without having to test and do some medical things, we can collect this data from her by measuring the features of a gland, and then we put it into the model, and then the model tells us whether she has if she has breast cancer or not, right? So that's what we'll be doing in the next class. All right, thank you, and see you in the next class.